Ever dreamt of being at the forefront of the automotive revolution, spearheading the transition to a cleaner, greener future? Now is your opportunity to plug into the pulsating heart of sustainable mobility with the unthrilling course Sustainability in Electric Vehicles. In this dynamic and interactive course, we unplug the mysteries of electric vehicle industry, setting you on a journey to become a beacon of sustainable change. Explore the groundbreaking advancements in EV technology, where innovation meets eco-friendliness, driving us towards a future that is free from any fossil fuels. Gear up for a thrilling expedition where you will not only learn about the mechanics of electric vehicles but also delve deep into the heart of sustainability. Enroll now on a free learning platform Great Learning Academy for the course Sustainability in EV and become a torchbearer of the electric vehicle revolution. So in this module, let's talk about the basic introduction of electric vehicles and the sustainability aspect of it. So what are electric vehicles? If I have to give you a brief introduction of what are electric vehicles in a very layman terms. So electric vehicles are basically the vehicles that are powered by electric motor and battery rather than a gasoline engine, right? So that's the distinction between an electric vehicle and a conventional gasoline engine, right? So there are basically three kinds of electric vehicles that are come up. One is the battery electric vehicles, we call it BEVs. Then there's something known as plug-in hybrid electric vehicles, PHEVs, and hybrid electric vehicles, right? So battery electric vehicles, as the name suggests, is purely driven by electric motor. Plug-in hybrid electric vehicle is mainly run by the gasoline engine. They have an aspect of using the electric motor as well, similar to the case of hybrid vehicle, right? So what in the component of a vehicle, what are the various elements that are there, right? For an electric vehicle, it is the battery, the inverter, as well as the motor, right? So in case of an IC engine, what we used to have an IC engine, we used to have a carburetor, we used to have different elements, right? The pistons used to run, fuel injector would be there, spark plug would be there in case of different types of IC engines, right? So that has all changed, right? So there are very less moving parts now when we talk about electric vehicles. The vibrations are less, the noise pollutions are less, the emissions of toxic gases are less, right? So that's the distinction that we have from electric vehicles to the conventional vehicles that we are used to seeing, right? So what are the basic components of an electric vehicle? We talked about battery, that is also known as the heart of an electric vehicle because it stores energy and powers the electric motor. Then comes the electric motor. So it converts the electric energy from the battery into the mechanical energy that is driving the wheels, right? The motion of the wheels. Then it is the drivetrain, the system that delivers power from the electric motor to the wheels. Then we talk about charging port, the port where the electric vehicle is charged from an external charging source, right? So then we also have something known as an onboard charger, which converts an AC power from the charging source to the DC power to charge the battery, right? So batteries cannot be directly plugged into an AC port, right? It has to be converted first into DC power to store the battery that is there, right? So onboard charger does that work, right? So in a nutshell, right, when we talk about electric vehicles, we also need to know that what is the historical significance of electric vehicles, right? So as we just mentioned that the distinction key parameter is electric motor and the propulsion is not there, right? So it is the batteries that run the system. It is the batteries that run the entire vehicle around, right? So what are the challenges that are there in this case, right? So the challenge is that the range of an electric vehicle is limited, right? We talk about conventional vehicles, right? The ones that run on petrol or diesel. So what is the advantage that you fuel it, it has a certain range, then you can refuel it, right? Instantly it will give you extra range, X range. But in case of electric vehicles, you need to charge those batteries, right? And charging takes time. So this is one limitation, right? You charge your battery once, it goes X kilometers. Then you need to find a charging station, right? Suppose you're going from Bangalore to, let's say, Mysore. So if your battery is fully charged, you can directly go to Mysore without any stoppage in between. But if the distance is, let's say, Bangalore to Bombay, then with the use of an electric vehicle, you would get X number of kilometers but after that you would need to find a charging station, right? So for that case, the infrastructure needs to be developed. And if the infrastructure is not developed, then the problem arises of why electric vehicles should be the primary source of transportation in today's world, right? So you can see petrol pumps on every X kilometers, but finding a charging station is something that is really difficult. But when we talk about the historical aspect of it, in the early EV, when we talk about the 19th century, the game of transportation actually started with electric motors. It actually started with electricity, right? You used to see electric carriages, trams that used to run. Then what happened suddenly that electric vehicles were dropped in the 19th century and conventional way of vehicles were adopted. The reason is because the constraints in harnessing that power to charge those batteries, right? During that time, it was industrial revolution and the world economy was growing. So during that time, what really happened is that the focus was industries, the growth of industries, and major sources of power, the thermal power plants or the power plants that were run by coal, they were asked to produce electricity for the industries to grow. Electric vehicles were not given that preference because you have something known as fossil fuels, which were readily available during that time, and it was easy to make vehicles that would run on gasoline rather than harnessing that power from thermal power plants and charging batteries and then running electric vehicles. So that was a tedious task during that time. But now in the current scenario, it's very easy for us relatively to develop an electric vehicle and find sustainability in keeping them as the future of transportation. So the recent advancements in battery and electric motor technology has spurred the modern EV revolution, right? So one thing that has come up in today's world is about how rapidly the technology is evolving, right? We now have moved from the conventional chargers to charge an electric vehicle to super fast charger, turbochargers have come in play, right? So the advancements are evolving, right? They're growing as the day pass. So it becomes easier for us to adapt to the new technology that is coming up, making the transportation as sustainable, as environment friendly as possible. So we talk about environmental impact of the conventional vehicles, right? So when we talk about IC engines, right? IC engine, they burn fuels to generate power, emitting CO2, right? Which is harmful. And even we talk about oxides, nitrogen oxide and the matters, right? So they pollute the atmosphere around us. So it causes air pollution, which is not good for our health or for anyone, the upcoming generations, right? So these emissions contribute to the air quality issues and various health problems it may arise, right? Tailpipe emissions from the IC engines, right? They are pollutants that cause various respiratory diseases, cardiovascular diseases, and decrease the air quality. So harmful effects include, right? So this is one thing that you would have seen in news as well when we talk about Delhi, right? Smog formation, acid rain, and the impacts, the negative impacts that have come on the ecosystem, right? So smog is a modern problem for air pollution, right? Acid rain is also one of the most important aspects of air pollution, right? So how can EVs change this scenario? How can EVs change the way things are going around, right? So EVs reduce the reliance on oil and minimize the vulnerability to oil price fluctuation and supply disruptions, right? So the biggest example of oil price fluctuations and supply disruptions we can see in case of the conflict between the geopolitics that have happened in around Ukraine and Russia, right? So the prices of oil has been skyrocketed, right? So the price fluctuations are a lot when we talk about gasoline, right? Gasoline engines. So in order to avoid that, we can have a constant source of electricity driving those electric vehicles, right? So we do not have to be dependent on the price fluctuations that are happening across the globe. So these things, right? These things reduces the vulnerability to the sudden price change, right? Imagine you having a full tank of petrol for, let's say, 500 rupees. Now the same would cost you 1000 if the price increases rapidly, right? You do not want that to happen, right? Your economics of your household would change. So in this scenario, it's good that electric vehicle would have a constant supply of electricity. It would not depend on these oil price fluctuations. Then diversifying energy sources, increasing the energy security, right? This is also very, very important aspect of it, that we need to diversify the types of sources. We cannot be heavily reliant on conventional vehicles, right? Gasoline vehicles, because what happens if sudden geopolitics scenario switches, right? So then we have to be secured in that regard. EVs can charge electricity from renewable sources like solar, wind, and hydropower. So electricity generation can be done from various ways, right? Some are conventional ways, some are renewable ways, some are non-renewable ways. So we should make sure that the electric vehicles that are charged from either solar, wind, or hydropower, or any other renewable sources, right? Because if we use non-renewable sources like, let's say, thermal power plants, then the entire purpose of building an electric vehicle fails, because at the end you're using fossil fuels to generate that electricity that would drive an electric vehicle, right? So the advancements are going on, the policies are in play, the regulations are, but still the developing countries are adapting it rapidly to this changes in how the energy to be used as electricity for the electric vehicles be from the renewable sources. So this integration enhances the environmental benefits and reduces the carbon footprint that I've been talking about. EVs produce zero tailpipe emissions, helping to mitigate the climate change by reducing the CO2 emissions. However, the overall emissions reduction depend on the energy sources used for the electricity generation, right? So at the end it would depend solely on the purpose that, yes, if you want to be carbon neutral, then the energy supplied to charge these batteries, electric vehicle batteries, should be from the renewable sources, right? So when next we talk about sustainability challenges and opportunities. So the production of EV batteries involve mining of raw materials, right? So the major component of an electric battery, right, is lithium ion. Lithium ion is the type of battery we use, so which can have environmental and social impacts. Now recycling and responsible sourcing of the materials are essential for the sustainable battery production. Then we talk about developing a robust charging networks to crucial to elevate the range, right? So we want to have an enhanced range and promote the widespread EV adoption. So charging infrastructure should be accessible, convenient, and accommodate different charging speeds. So EV can serve as an energy storage device and participate in the demand response program, helping balancing the grid. What does this mean? This is a technology called V2G. We will talk about in the subsequent modules. So smart charging and V2G technology enable optimized energy used and reduce the strain on the grid, right? So it's basically, V2G is basically having a communication between the vehicle and the grid, right? So this communication should be smart. How? So basically, if I talk about you charging from a grid, right, from a charging station, now you have excess, let's say, a battery left in your electric vehicle. You go home and there is a blackout, you don't have electricity, so the vehicle can provide electricity for your household. So that is what essentially it's communicating between, so there is no wastage of electricity anywhere, right? Basics of battery technology. Now, batteries store and provide energy to power electric motors in electric vehicles. Now, they play a very vital role in determining the vehicle range that is there, the performance is there, and the overall efficiency is there. Lithium-ion batteries are commonly used in electric vehicles due to high energy density and rechargeability. Now, they consist of an anode, a cathode, a separator, a electrolyte, right? So, these are the main elements of an electric battery. So energy density refers to the amount of, so this is very common term and very important term when we talk about battery technology, that is energy density. So it refers the amount of energy that a battery can store per unit volume of the weight, right? So this is to be noted here, that energy density is a very, very important term. Also, capacity represents the amount of charge a battery can hold, determining the range of an electric vehicle can travel. right? So the reason why lithium ion batteries are used is due to high energy density and rechargeability of that battery, right? Then battery components and materials. Now anode, typically made from graphite or other carbon materials, it stores lithium ion during charging. Now anode, let's talk about the various components here. So anode is basically made from graphite or anything that has carbon in it, right? So it stores lithium ions during charging. Cathode is made from lithium cobalt oxide, nickel cobalt manganese oxide, or iron phosphate. So it stores lithium ions during the discharge. Now, electrolyte is a conductive medium that enables the movement of lithium ions between anode and cathode. This you must have known in chemistry in class 11th, 12th, or even 9th for that matter, right? Electrolyte was there. Cobalt, nickel, and manganese. So these transition metals are crucial for the cathode materials in lithium-ion batteries. Their ratio influence the battery performance, energy density, and thermal stability, right? So for a battery, it's very important to have the performance that is right, the energy density, and also the thermal stability should be maintained. Battery performance and safety. Now, repeated charging and discharging cycles lead to the battery degradation over time, right? So, you do not want your battery to just fade away and you need to get a new battery, right? It should at least last for 5-6 years, right? Running. So, repeated charging and discharging cycles can lead to the degradation over time. Factors like temperature, depth of discharge, charging habits affect battery lifespan. So what does this mean? This means that the repeated charging and discharging cycles lead to battery degradation over time. Factors like temperature, depth of discharge. Now, the batteries that are run in places that the temperature is high, let's say Delhi, during summers it's 45 plus degrees, right? So the degradation happens quite quickly in those areas rather than the areas, for example, hilly regions, right? The overall temperatures of the places are less, right? So the degradation of battery due to the temperature is less. So the battery lifespan increases, right? So maintaining optimal operating temperature prevents overheating and thermal runaway. Factory measures include battery management systems that monitor and control the cell performance. It's also a very, very important aspect that to include the BMS in the vehicle, right? BMS is always there, which maintains the health of the battery at all times. Proper recycling of batteries is essential to recover valuable materials and reduce environmental impact, right? So it should not be the case that you are running the batteries, then you throw it away. No, you have to recycle the batteries, maybe give it for exchange, get a new one and replace it, not throw it. Disposal without proper procedures can lead to hazardous waste and pollution, right? So we can see this, it's very evident that if a battery leaks, it's a source of very hazardous waste and the pollution, or even if you throw it away. Not even batteries that I'm talking about, lithium ion batteries or something of that sort, even the normal AA batteries, AAA batteries, that also if thrown away is a hazard, is a pollution right there. Sustainable vehicle design and manufacturing, right? Before starting this module, let me ask you this question. What do you think a vehicle, right, be it car or anything, what are the materials it's made up of, right? So think about it. Sustainable vehicle design and manufacturing. So design principles for EV sustainability. Number one thing would be the first important element when you talk about design principles of EV sustainability is light weight of materials, right? Imagine having a car made up of iron, right? It would be very heavy for the vehicle to be on road, right? So we generally use steel or aluminum, right? So using lightweight materials is very, very important, right? So consideration of lightweight materials is not like you can use plastic. It's about durability, strength of that particular material, right? So EV benefits from materials that are both strong and lightweight, right? Lightweight means strong and lightweight, such as carbon fiber, aluminum, and high strength steel, right? So this is a particular byproduct of steel that is known as high strength steel. So various parameters are different, percentage of carbon is different, various elements in this are different, right? So carbon fiber is the best element to be used, but you cannot use it because it's very, very expensive to manufacture that particular carbon fiber. So that is eliminated right away. But if you could see the supercars that are being, they are built on carbon fiber. If you consider Formula One cars, they are also made of carbon fiber, because in that case you want efficiency, you want performance, right? You don't want the weight of the car to increase to hamper your performance. So in that case, carbon fiber is used. It's a very, very expensive material to add to a car, right? Or expensive cars like let's say Lamborghini or these types of super Ferrari cars, right? So they all use carbon fiber to manufacture, because in that case money is not an issue, performance is. So that's why they use it. But for production cars, right, the cars of day-to-day use, carbon fiber is not used. Aluminium or high strength steel is used. So reduced weight improves energy efficiency, extends the range and enhances performance. So considering an electric vehicle, right, you don't want additional riders to be imposed to the performance, right? Weight is one such rider in which you want it to be as low as possible. Then we talk about, after the first element, second element is aerodynamics. So streamlined vehicle shapes and optimized airflow reduces drag, enhances both efficiency and range, right? So if you want to see the evolution of the designs of car, right, it has always been through the parameters of aerodynamics, right? So it's more streamlined in that way, that the air, right, whenever the air hits, so you're driving the car, so you would feel the air that pumps in your vehicle, right? So it should not be like a bus where the air flow is blocked. It should be more streamlined in a way that the air, right, the wind tunnels that is built to test out the aerodynamics, right? So they should flow across the vehicle so that you would reduce the drag that is present, which would again help in efficiency and range. So wind resistance is a significant factor in EV performance, right? Sustainable material, right? So this is the third element that is important. Incorporating recycled and bio based materials in vehicle construction lowers the environmental footprint. For instance, using the recycled plastics for interior components reduces the demand for virgin plastic. What does this mean? This means that anything that is new, with that, the fresh plastic that is being built, that should be minimized. The untouched plastic should be minimized. The one that is recycled over and over and over again is the one that needs to be used, right? Interior components, you would not need any new sort of plastic. You would not need any virgin plastic to be added. It should be the one that is recycled and added. Then we talk about eco-conscious design. Selecting materials with low energy requirements and reduced emissions in their production contributes to the overall sustainability. Selecting materials with lower energy requirements, it's a very important term, and reduce emissions, their production contributes to the overall sustainability. Now, manufacturing processes for EV. What are the process that involves in manufacturing? It's mostly the same. The assembly lines are the same, but where the engine assembly is there, that is not there. Little bit differentiations are there, so let's check that out. So powertrain assembly, right? EVs require unique powertrain components like batteries, electric motors and power electronics, which necessitate the specific assembly processes. Then comes simplification. Fewer moving parts in EV powertrains can simplify the manufacturing and reduce the complexity in comparison to the conventional internal combustion engines, right? So it's good that electric vehicles have very fewer moving parts, right? In an IC engine, you have the carburetor, you have the pistons, you have what else do you have? You have the spark plugs, you have fuel injectors. So these are the elements that are there. You have a full radiator that runs, right? So you have a lot of moving parts that are there, right? Gear assembly in itself is a moving part. So in this case, when we talk about EVs, that is completely gone. You don't have a roar of an engine. It's the batteries that you would hear the sound of bit. not much. So the noise pollution is also reduced in that regard, right? So the complexity of the design is also reduced. You don't need a very big hood space to attach your engine, right? You have batteries that can be placed on the lower level of the car, right? Where you put your foot, right? So that lower base of the chassis can also be used to add the batteries, which is used in most of the cases. So you would have luggage space both at the front and at the back, right? That would be increase in terms of the load carrying capacity of the electric vehicle, right? So utilizing energy efficient equipments, renewable energy sources, and optimizing production line layouts contribute to low energy consumption during manufacturing. So the consumption during manufacturing, assembly lines, right, it should also be reduced, right? So that's also very one important factor to consider. Process optimization. Learn manufacturing practices that minimize waste, reduce energy usage, and streamline production. One such is work systems engineering, right? So these are the different kinds of energy layouts that are there in an assembly line production, right? How to make sure that planning of that particular plant is optimized, that reduces the overall consumption of energy in any regard, right? So that should be the focus when we talk about the manufacturing of EVs as well. Collaborative approaches and industry initiatives. So collaborative efforts among various manufacturers are there, suppliers are there, various stakeholders are there that promote sustainable sourcing of materials, right? So instead of using long haul, let's say IC engine trucks, you can use trains that are run on electricity, right? You can use trains to transport the raw materials from place A to place B, right? Partnerships ensure transparency, responsive mining practices, and ethical supply chains. So again, right, mining practices, why you would need certain elements that are there, certain elements that you need to use for the manufacture of battery, right? So the practices should be as low carbon footprint as possible, right? Industry recognized certifications like ISO 14001 and LEED validate the environmental conscious and manufacturing practices, right? So these regulations, right, adding ISO certifications and all that also helps in reduction of the energy wastage that happens, right? If you have more regulations in play, the better the finalized product would be. Certification helps consumers identify products made with reduced environmental impact, right? So this is also very important element, that identifying and making aware of how this electric vehicle is going to help is also one important aspect.